Well, welcome to this next tutorial on using nowRail. Today I'm going to be looking at using the PCA9685servo driver board to control servos, and what we're basically going to build is this. And what we see here, obviously we've got the ESP32, we've got a PCA9685 servo board. I've put one down here because it's easier to see than the odd angle that the camera's got it. And then I've got obviously 4 servos connected. I've put this one on its side so you can see what it is. I tend to use the MG90 servo as opposed to the SG90, which is this blue one. The real difference between them is the MG90 has metal gears, the SG90 has plastic gears, and there's about 10p difference in the price, so I just buy the metal geared ones instead. The other thing that you will see on the breadboard, I have got a separate 5-volt power supply coming in. We'll see why when we look at the circuit. And then over the back here there's an ESP8266. You might wonder what this is doing, but this is actually sending out the commands to this board, which is moving the servos. Now this project to me is actually quite an important one because those servos happen to be moving at exactly the right position to run the points on the right hand board of my layout, the Isle of Mud. So let's get into how this is done. So as always, the resources for this tutorial are on the Digital Town website, and if we look at the nowRail page, I'm going to click on the PCA9685 servos, and it takes us down to the instructions on how to do this, some written instructions. Anyway, let's take a look at the circuit. Here's a bigger version so we can see what's going on. So a PCA9685 board, I've done some separate tutorials on these. They're on the, again, the Digital Town website. These boards allow you to drive 16 servos. They start off at port 0 and finish at port 15. For my layout, this particular base board that I'm working on, I only require 4 servos. Now the way these boards work, if you look, you've got a yellow PWM pin, you've got a red V plus and a black ground. These boards, I've got here a separate 5-volt power supply, and I've got this circuit diagram here in the way that I would have it configured on my layout. So although on the breadboard the ESP32 is being powered by the USB, when I put them on the layout they are all powered from a separate 5-volt supply. So the 5 volts comes in and it goes to the VIN pin on the ESP32. The ESP32 runs at a 3.3 volt system. So supplying it with 5 volts is quite enough for it to drop it down through the voltage regulator to give the board the 3.3 volts it needs. I've also got the grounds, a common ground. All the grounds need to be common. The more complicated bit comes with the 5 volts. So I'm supplying 5 volts into the ESP32. I've also got 5 volts coming from the power supply to the V plus pin, but next to the V plus pin there is a VCC pin. Now this power supply is coming from the ESP32, which of course is running at 3.3 volts, so just don't connect the two together, because obviously the ESP32 does not appreciate 5 volts. So the grounds are common. Then I've got pin, hang on, let's bring the my little pin out diagram so that we can see what's going on here. We've got pin 22, which is this pin here. That is our SCL pin, which connects to the SCL here, the green, and then we've got, as we look at this, we've got the SDA, which is connected to pin 21. That's the circuit. That's all there is to it. Obviously on mine, each servo plugs into a different port. The wiring became a little bit complicated, so it looks like they're using a common plus and a common ground. You could do that, but obviously I just plug them in to the individual ports and they work that way. So that is the circuit. That's how we get started. Right, let's get on with coding this up. Okay, so we're in the Arduino IDE. Obviously it might look different to yours. That's because in my preferences I use the dark theme just to help my eyes. So what I've done is I've taken a copy of the nowRail program. You might notice at the top that I am on 0.3. On the website it's 0.2. The only difference between them is there is one line of code that has been commented out because it was a serial print statement that got left in. As I'm working through this, I also find out any bugs during my testing. So what I did was I made a copy of the nowRail system. I have saved it with a different name, PCA9685servo version 1. So that's what I've called it. I have then gone down to, where are we? The setup, and I've put my name in the setup so that when I restart the sketch I'll know what sketch this actually is. And then the only other thing that I've done here is in this area I have written down in advance what I am trying to achieve. So let's just have a look at this because it can affect how you use the nowRail system. Now, for those of you who use DCC, realistically, you are restricted to just over 2,000 accessories. I think it's about 2,048 with some systems. So the way that nowRail works is if I had the system connected to DCC-EX, or later on it'll also go to what do you call it, LocoNet or something like that. I'm working on that for later on. But only addresses of a value of 2,000 or lower will get sent to DCC. There's no point sending addresses that are higher than that because the system won't even understand what they are. So on my layout, on my traverser, I'm using a traditional DCC decoder. So I want that signal to go via my DCC-EX system. However, these higher value, these servos that I'm controlling, I don't even want DCC-EX to know about them. It doesn't need to, they're going to be controlled directly. So the addresses I've picked are 2005, 2006, 2007, 2008. That's because on the left-hand board it's 2001 to 2004. Right, the next thing, I have already decided which ports on the PCA9685 board each of these items is going to be plugged into. One of the things I then do on my sketches, I tend to write I leave this information in the sketch. Sorry about the coughing, still not feeling so good. But I actually write a description here. So when an instruction of 0 is passed to accessory number 2005, I want the turnout or point to switch to the main line. If I send a value of 1, I want it to set the track towards my carriage works. Now that might not seem anything to you, but that just tells me which point I'm talking about. Now you'll see after this I've got two numbers, 67 and 96. Now I did a project on the Digital Town site called the Servo Setup project, and the Servo Setup, and there's a link on the Digital Town site. I've put it in, where is it? He says looking for it. maybe I've got to press refresh to get the update. Yep, there it is. So I'm constantly adding material. So when you go on the website to the PCA9685 driver boards and servos, there is a link to the Servo Setup project. It's a very simple bit of code with a few buttons that you can just set up on a breadboard that will allow you to quickly set a servo for your layout if you're going to be using servos to control turnouts. So because I've already done that, I know all the positions of my servos, so I know that when a 0 is sent, I want this servo to go to 67 degrees. When a 1 is sent, I want it to go to 96 degrees. And that's what those numbers are, just so you know. So, right, let's get on with the next bit. So let's do some cleaning up first. So we've got our nowRail include, we've created our object of nowRail. Obviously I'm still using the default address. In the ones I'm using for my layout, obviously I've set my own personal layout address. Now we're going to get rid of the stuff that we don't need. So because this is going to use standard built-in functions, we don't need that. We also don't need any of the custom function codes. So I can delete the now moment button. I can delete down, keep going down, now accom received. I can get rid of now time events. Basically, I can clear, my time events, all of these functions, everything down to the setup, deleted. Fantastic. That can come out of the main loop. Don't need that. And I don't need that. That's better. So now the code is very, very simple. We're now going to go to user setup H, and we're going to set up the various systems that we need to run. So user setup H. Now for a PCA9685 board, we need to include the wire library. So I'm going to uncomment that. The instructions for doing this are on the Digital Town website, so don't worry if you can't keep up with the video. Now we're going to be using the PCA9685 boards, so we're going to uncomment this line. We're going to uncomment this line. Now just to explain what this is, this variable basically tells the system that at the moment we're just using the default number of a maximum of 5 PCA9685 boards. Now if we go back to the web camera and we look at this particular board, if you look here, there are 2 tabs that have been soldered across, and these are the way that you can change the addresses of these boards, so that you can actually, what I could do with this is daisy chain this onto this board or set it up in a different way, but they can basically, you can run multiple versions of this board. The default for nowRail is 5, but I forget how many you can have. It's a lot. I know you can finish up with about 900 servos off one board if you need it off all daisy chain together. So today we're not going to be using 900 servos, but if you did need to add more than, if suddenly you needed 10 boards daisy chained together, what would that give you? That would be 100 and, what was it, 16 each, is 160 servos. That's a lot of servos, but if you do need more, just change this value here. Now the next setting you'll see here is servo min and servo max. These are to do with the way that the servos work. There is certain frequencies that are sent to them, certain PWM frequencies that the servos just don't react to, or they react in a very weird way. This is just a setting that is in there to make sure that the servos work within their good band of operation. The other thing, just to make sure that it's turned on, is diagnostics on. When you sort of finish the system, then you would turn the diagnostics off. but it's quite useful for testing because you can see the commands coming in and you can check that your servos are moving correctly. The rest of it stays the same. So let's get back now and look at how we set up the servos. So going back to our main screen, what I'm going to do is take this information. I'm just going to copy it. And we're going to bring it down into the setup. And then I'm just going to comment it out. And the only reason for doing that is it just puts the information in front of me so that I can see what on earth I'm doing. Now, if we go back to the Digital Town website, the function that we are going to be using is this one, add PCA9685servo and its various bits and pieces that go with it. So let's just copy that and paste it in. Hopefully that will paste okay. Yes, it does. Fantastic. Now, one thing that you do need to do is put the my layout dot in front of it, and that is because when I set this up, the nowRail, when I created the object, I called it my layout. So just something for you to be aware of. Now, as we look at this, we've got a byte, that's the board address, the port, the accessory number, the angle, when a 0 comes, instruction is sent, the angle when a 1 instruction is sent. So this is pretty easy now. I can look, I know the board is the default address on this one because I have not soldered across any of the tabs on the board that's plugged in. If you have soldered across the boards and you want to find out what the address is, what you need to do is go down in your Arduino IDE, go to the wire library and run the sketch wire scan. And if we just bring this sketch up, what it will actually do is it will scan the I2C bus for any device that is attached, and you'll get a list of boards that are on the system. It'll give you your address. That's all you need to do to find out the address that you're going to put in here. So I know in advance that mine is 40. Then with this first item, I know that I'm plugging into port 0. The accessory number for this particular item is 2005. The angle that I want this to set to is 67 when a 0 is passed, 96 when a 1 is passed. That is that servo setup. So let's just copy that down, and we're going to change that. We've got a 1, 2, 3, 6, 7, 8. Right, let's put these other values in so I can see here I need a 64, a 100, an 85, '52, 70, and 10. Done. Now bizarrely, that is all that is needed. Now when an instruction is received, it will know that it knows if the instruction comes in for accessory number 2005, it will know where it's plugged in, which board it's plugged into, what position it needs to move to, depending on the instruction sent. That is the end of it. The only thing that we now need to do is click the compile button, and that's it. He says, hopefully. Has he missed anything? Come on. By the way, for those who've never used ESP32 boards, they can be a little bit slower compiling than your normal old Arduino boards. That is because the library, because of all the items, basically all the little toys and extras that the ESP32 boards can do, tends to be quite big. Now, some of them, by the way, when you see these dots, sometimes you need to press the boot button. So I'm just going to quickly press that boot. Oh no, it's done it without it. What I've discovered is if I've got a really good power supply, it doesn't need the boot button pressed. If the voltage is a bit low, it does. Right, that's it. All done. If I click the serial monitor, there is absolutely nothing happening. And the reason is the servos at the moment aren't moving because nothing's driving them. So let's get them driven. Now, the reason nothing's driving them, or why the servos aren't moving, has got nothing to do with the ESP32. It's all plugged in, it's running, everything's working great. The problem is there's nothing sending a command to it to tell it to move anything. So that's what we're going to use this ESP8266 to do. And all we're going to do is get it to send some commands over. You'll notice there's no buttons attached. We're not going to need any buttons. We're going to use time instead. So let's have a quick look at the code. So once again, I've taken a copy of nowRail, and if I go up to the top, this is still the version 2, the old one. So I've got the address in that's correct. Now you remember those functions on the first screen that we deleted for the previous sketch? We're going to use one of those now, because these functions are used for custom items. Therefore, things that you want to happen that I can't imagine would happen, so I'm not going to write a function for them. So one of the events we're going to use is the now time events. So the time events, this function, every time a layout second passes, not a real world second, a layout second. So that could mean that, you know, if the clock speed is set at 255, this function is going to run 255 times per second. In fact, even now I've got it running at 4 times speed, just to speed things up a bit. So as you can see, we get the clock speed, the hour, the minute, the second, and the day. nowRail runs on a 7-day system. Choose whichever number you want for whichever day you want. I sort of start with 0 for Sunday. So we've got these variables being passed, and all I'm doing is using a switch statement on the clock second. So the number of seconds past the minute, and what I'm saying is if it's 5 seconds past the minute, I want to send an instruction to accessory 2005. I want to send it an instruction of 0, and I want a response. This is actually gives a value of 1, as we can see in that define statement. And 1 means that when I send this instruction to the PCA9685 servo system that we've got, it will send a response back to say, I have now processed that message. That's to do with just making sure that message got there. I've then done one at 15 seconds past, 25 seconds past, 30 seconds past, 35, 45, 55, and 59. Now, to save me waiting, what I've done to make this work, I then go into the user setup, and all I've done is I've turned the master clock on. The master clock means that this will broadcast a time message to any of the boards on the system, and they will all synchronize. And then in the back to the setup, one other feature that I had to add was this function, my layout send clock speed change. And what this is doing is it's telling this board that it's actually sending a broadcast all over, but it's basically sending a message out saying, I want the clock speed to be running at 4 times normal layout speed. That's just because otherwise you've got to sit for a whole minute to watch the servos move. So let's get those back on. What I'm going to do is pull this over here so we can now see. Let's clear off this. We can now move this one over so that we can see the other serial monitor. So at the moment nothing's happening. I'm now going to turn on that board, and immediately we start to see the servers moving, and we can see the diagnostics saying that the various commands have been received and acted upon. In fact, what we'll do is we'll just stop this for a second and just take a look at what it's doing. So we can see here that the accessory command has been received. Notice it's the master clock, so we see the clock time has been set, it's been synchronized to the other board. A accessory command has been sent out, and a command has been sent to 2008 accessory number with an instruction of 1. The system has now acted upon that, and then what it's done is it's sent a response back of a value 2 that tells the PCA the ESP8266, the D1 Mini, that its instruction has been completed and you don't need to send me any more reminders. So all you're looking at down here is the set of instructions, if you like, the communication response between the two. And as we can see, as we look at what's going on here, everything is working exactly as I wanted. That is now ready to go on my layout. That's the end of it. So hope that's been useful to you, and I'll try and do some more videos to get the rest of the instructions on these boards done. And if it is helpful, please, click the like and subscribe. Also, if you have any subjects on the nowRail system that you really want to know about, or maybe some features that need to be added, just stick them in the video comments and I'll see what I can do about them. Bye for now.